In lecture 9, we're going to focus on functions. So we'll start with some examples. So let's suppose that y is equal to 250 minus 10x, and we're going to restrict this function so x only ranges between the values of 0 and 25. So let's construct a table and graph this function. So one way to rewrite this as a function is just f of x is equal to 250 minus 10x. So you should really think of a function as a rule where you're going to take these x values and get an output. So the x in this situation is like your input, and you're going to get a unique output. Okay, so first let's follow a similar strategy that we did before, which is you can construct a table. So we're going to look at the values of x and y ranging over this. Okay, so since x is only allowed to range between 0 and 25, maybe let's use increments of 5. So 0, 5, 10, 15, 20, and then 25. Okay, so if we substitute these values in, just like we did before, so here we would get 250, and then 250 minus 50 would be 200, and then 250 minus 10 times 10, 150, and then 100 if we substitute 15. If we substitute 20, so minus 200, we'll get 50. And then finally, if we substitute 25, we'll have 250 minus 250, which would be 0. Okay, so one thing that we can designate with a function is the domain and the range. So the domain is the inequality that the x inputs vary over. So this would be the given right here. So a lot of times you're usually given a function and specified domain, or you can sometimes determine what the domain is based on the type of function that you have, and that's usually called the natural domain. So the inputs range over some interval, right? And we could rewrite this as the interval from 0 to 25, and we'll use the square brackets to denote that we're including them, just like we did before. And now the range, what is the range? Well, the range is the outputs. The outputs, what are we getting? Well, we're getting anything from 0 up to 250. So it's the y values that we're getting. So from 0 to 250. Okay. And we can graph this. Now, how should we do that? Well, we're incrementing by 5, so maybe we'll denote that down here. So this is 5, 10, 15, 20, 25. And then the y values, since we're incrementing this way, maybe we'll increment by 50s. Okay, so 50, 100, 150, 200, 250. Okay, so then we can plot our points. So at 0, 250, we're getting our first pair of points. 5, 200, 10, 150, 15, 100, 20, 50, and then 25, 0. And then all the values in between this, right? Since those are matching up to potential inputs. Okay, so one thing you need to know about a function is if the domain is specified, we must have an output for every single one of those inputs, right? So every one of these x values from 0 to 25, there must be an output, okay? And more importantly, to make sure that it is a function, you can only have specifically one output. You can't have more than one. So a function actually has to pass what's usually called the vertical line test. So if you were to draw a vertical line anywhere on this graph, it can only intersect the function at most in one spot. All right. Okay. Good. So this is, I think we've done everything that was asked for. So construct the table and the graph, and that's what it looks like. I suppose that we should make a note of this since we kind of pointed it out already. So the graph of a function must pass the vertical line test. Okay, so if you were to draw a vertical line anywhere, so let me switch the color of this. Okay, so let's say that it's red. Okay, so if I were to draw a vertical line anywhere, then it's only going to intersect the function at most in one spot. Now, if I pick anywhere, right, so why do I say at most one? Well, if I drew this vertical line, it doesn't even intersect that function because the domain, this x value is not even part of that domain. Okay, so but you can pick here your vertical line anywhere, and it should only intersect that function at most once. Okay. I mean, another way that you could rewrite that is something like this. For every input from the domain, there is exactly one output. Okay, where what I'm saying here is the input must be part of the domain. Okay, that's another way of specifying that. So when we do functions as consider them as sets of pairs of points, then in the next example we can come back to that. So let's look at some examples where we kind of consider functions in their formal set theoretic definition. In the book, we introduce the notion of relations. So a relation is just a rule that pairs each element of one set, which we call the domain, with one or more elements from the second set, which is called the range. So we actually saw an example of this up above, but an alternative definition to a relation is it's just a set of ordered pairs. So the set of all first coordinates, that would be the domain of the relation, and the set of all second coordinates is the range of the relation. So here we have two examples. We have a set of ordered pairs, and we want to be able to give the domain, the range, and determine which of these are functions. Okay, so in the first collection, what would the domain be? So the domain, this is just going to be the collection, the set of all first coordinates in these pairs. So the domain would be the set of, so this would be 2, 4, 6, and 8. Okay, the range will be the collection, it'll be the set of all of the set of all second coordinates. Okay, so we have 1, 3, 5, 7. So then the set will be 1, 3, 5, 7. And again, as we discussed, above, a function is just going to be a rule that pairs each element in one set, which we call the domain, with exactly one element from the second set, called the range. So in other words, just a function is a rule which for each input is paired with exactly one output. So this example right here, each input is paired with exactly one of these outputs, and therefore this would be a function. Okay, so this relation is a function. Okay, how about the one down here? Okay, so here the domain. We have the set, looking at the first coordinate, 0, 1, 2, 1. So that set is actually just going to be 0, 1, and 2, right? We don't have repeats when you have sets. So 0, 1, 2, 1, we would just write that once. And the range, this will be the set of the second coordinates. So this will be 4, 6, 4, 5. So 4, 6, 4, 5. So 5 and 6. Okay. Now here we have a problem, right? Because if you look at this pair and this pair, right, then we have an element of the domain, which is 1, and it is paired with two distinct values of the range, and that would not be considered a function because of that, right? You have it would be as if you had a function where you tried to plug in, right? The first coordinate is what you're trying to plug in to get the output, the second value. You tried to plug in 1, but you're getting two outputs. You're getting 5 and you're also getting 6. And so this is not a function. So this, but it is still a relation. This relation is not a function. Okay, and relations are still important. So we have seen and will see examples of nice equations that describe these relations, and they may or may not be functions. Okay. I actually did just think of something interesting. Let's go up to this example again, and let me add in another example. Okay, let's say that we had the following. So 2, 1, 4, 3, 6, 5, and instead of 8, 7, what I'm going to do is I'm going to change that output. Instead of being a 7, I'm actually going to repeat one of these outputs. Let's say that I have a 1. Okay, so what would the domain be? So the domain is still actually the same, 2, 4, 6, 8. 2, 4, 6, 8. The range, the set of outputs, so 1, 3, 5, 1. So we only have 1, 3, and 5. Okay? But this is still actually a function. So this relation is a function. Okay? Because every element of the domain is paired with exactly one element from the range. 2 was paired with 1, 4 was paired with 3, 6 was paired with 5, and 8 was paired with 1. Now, it's not a problem if the output gets repeated like this. It just means that 2 maps to 1 and 8 maps to 1. Okay? That's perfectly fine. Okay, it's just situations like this where you have two of the inputs repeat. Okay, 1, it would be as if you plugged in 1 and you're getting 2 outputs, and that is something we don't consider a function. But over here, if I plug in 2, I'm getting 1. If I plug in 4, I'm getting 3. If I plug in 6, I'm getting 5. If I plug in 8, I'm getting 1. There's no issue there, right? it just so happens that plugging in 2 gives me 1, but also plugging in 8 gives me 1. All right, that's fundamentally different than plugging in 1 and getting 2 distinct outputs. Okay, so let's continue. So now we're going to start with, for each of the following graphs, we're going to give you a graph, and we want to find from the graph what's the domain and the range and determine which represents the graph of a function. So in this first example, we have this red curve, and these arrows are indicating that drawing would continue forever in that sort of specified direction. Okay, so first let's state what the domain is. So the domain is going to be the collection of x's, right? So what x's do we have here? Well, we certainly have all of the ones here. You know what, let me switch to a different color. So let's switch to maybe blue here. Okay, so the domain, so what would that be? So do you see that we definitely have these inputs because we're getting outputs there? Okay, so for example, this x input here is getting this, it's corresponding to that point. So this x, whatever that may be, let's call it x sub 0. Okay, x sub 0 is corresponding to y sub 0. Okay, and that y sub 0 is over here. So what are the inputs? Well, we can plug in any of these values. We're getting outputs, right? Any of these values, we're getting outputs. But it's continuing forever because of these arrows. So we can plug in over here, and it looks like there's no restrictions, and plug in over here. So it doesn't look like there's actually any restrictions on things that are we can plug in for x. So the domain in this situation would be all real numbers. So negative infinity to infinity, or we could write it like this for all real numbers. Now the range, on the other hand, this is a little bit different. Let me switch colors again, maybe purple. Okay, so for the range, what's going on here? So now we're looking at the collection of outputs. Well, here is an output right here, but this is continuing up here, right? We're getting some points that correspond to these, and it continues forever. Okay, so there was actually no indication of how this was incremented. So I guess if we assume that it's incremented by ones, that this would be at negative 2. Okay, so the range in this situation, now negative 2 is going to be included, right, because that red curve does pass through that point. So we are going to include negative 2. But then because this continues on, our outputs can get as large, arbitrarily large. So it will go from negative 2 to infinity. Okay, so that takes care of the domain and the range, and determine which represents the graph of a function. Well, how do we determine that? Well, you remember above we said that if I give you the graph and it passes the vertical line test, so draw any vertical line, and it hits that function or that curve, we hope that it's a function, at most in one spot at one point, then that will that'll be the graph of a function. So the answer is yes, this is a function. Yes, this is a function, since it passes the vertical line test. Okay, now we can also classify what kind of function this actually is. So another test that you can actually do is called the horizontal line test. So if you draw a horizontal line and it hits the curve in at most one spot, then we say that that is a one-to-one function. So a one-to-one function is one that passes the horizontal line test. So note, this function does not pass the horizontal line test, because if I draw, say, a horizontal line here, it will hit in two locations, right? So if I were to draw this horizontal line, then it would hit here and it would hit here. So that does not pass the horizontal line test. This function does not pass the horizontal line test. Horizontal line test. So it's the same thing as vertical line test in its substance. You know, just draw a horizontal line instead, and it should only hit the curve at one spot. But here it hits two spots, so it does not pass the horizontal line test. So this function is not one-to-one. Okay, so a one-to-one function is one that does pass the horizontal line test. Okay, so what's actually happening here? You're actually getting you're taking two distinct inputs and getting actually the same output, which is actually what happened in this second example that I gave over here. Do you see that? Where are we? So this point and this point, right? We had two distinct inputs, but we got actually the same output. So this would be a function, but it would not actually pass the horizontal line test, because it would hit these 2 points. So this is a function, but this one would not be one-to-one as well. So considering another example like this one, what do we have in this situation? So the domain here, what are the allowable inputs? Are there any restrictions here? Well, it looks like we have inputs for all real numbers again, right? For every single one of these x values, there is an output, right? So for this x value, we are going to have this output here. Okay, so anything in this purple, we have something as an output. This is definitely a function. It passes the vertical line test, right? And this continues on. So since the curve has these arrows, we know that it doesn't stop abruptly. So the domain in this situation is negative infinity to infinity, or another way to write that is all real numbers. So what about the range? So in this situation, what are the possible outputs that we have? Well, here's one output, right? But it looks like for this portion of the curve that continues on after this point, we have all of these outputs, right? Similarly, down here, once we get past, say, here, and this curve continues on, then we have outputs in this region. And then in between these two, there's definitely several times some of these outputs are actually made, right? So for example, this output is made at this point on the curve, and this point on the curve, and this point on the curve, which is perfectly fine. We just happen to have 3 inputs that go to the same output, right? This input goes to this input goes here, this input goes here. But all of these y values are definitely outputs. So unlike the previous example where the range was slightly restricted, this one we are going from negative infinity to infinity. Okay. What else do we want to do here? So let's classify this. Well, it's definitely a function, and so this is a function. Since it passes the vertical line test, right? Sorry, let me erase this. Okay, so since it since it passes the vertical line test, but it is not 1-to-1. And why is that? Well, it doesn't pass the horizontal line test. So for example, the horizontal line that passes through those 3 points I was just talking about, it hits the curve in 3 spots, not just 1, or at most 1. So it is not 1-to-1. Does not pass the horizontal line test. Okay. In this example, what do we have? Well, we have it doesn't look like we have any restrictions on inputs, right? We definitely have inputs across this portion of the curve, right? All those x values are inputs to get to the red portion on the curve, but since this continues and doesn't stop, we keep going in the positive x and the negative x direction, and so the domain here is again negative infinity to infinity, or all real numbers. But what about the range? Is the range restricted in any way? Are the outputs restricted? Well, it looks like we have outputs up to here, up to that top point, but then this curve doesn't continue anywhere up here. So this is essentially the largest x value that we're getting. And going in the negative y direction, right? So this is the largest y, the largest output that we're getting. And we continue in the negative y direction. So the range is from negative infinity to this maximum value. And since it wasn't indexed in a particular way, let's just assume that it was indexed by 1s. Sometimes I'll label those, but in this situation it wasn't labeled, so let's just assume it's by 1s. We would go up to 3. And we'll include that because that point is actually exactly where that maximum actually is. It's inclusive, okay? And this is a function, so it passes vertical line test. So this is a function. This is a graph of a function. But again, it doesn't pass the horizontal line test. So for example, I can make a horizontal line here if it was horizontal. Maybe I'll try that again. Okay, there we go. So a horizontal line, but it actually hits the curve in 2 spots instead of just once, or at most once. So it fails the horizontal line test. So that means it is not 1-to-1. Okay, in this situation, it looks quite interesting because now we have a curve and it doesn't look like there's any arrows indicating that it's going to continue on in some general direction. So what are the inputs we have? Well, assuming that it stops right where it hits the y-axis, it looks like the inputs start at x equals 0, and we keep going and 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 keep going all the way up to here. Okay, so remember, a curve is just a collection of points, so the domain is just going to be the collection of x values, right? The first coordinate values. So if this is indexed by 1s, so 1, 2, 3, it looks like the domain goes from 0 inclusive all the way up to about 2.5, so 2.5. And it looks like it's inclusive there. And then the range, what are the second coordinates, right? Sorry, the second coordinates range, the y values range between these two. So it looks like that goes between -2 and 2, if those are indexed by 1 as well. Up to 2, -1, -2. Okay, now is that a function? Well, it doesn't pass the vertical line test. You see, I could draw this vertical line here at x equals 1, and that hits the curve in 2 points and that's bad, right? So this fails the vertical line test. So it is not a function. Okay. Now, in order to be a one-to-one function, it already has to be a function. Okay, so even though that this curve passes a horizontal line test, in order for you to have a one-to-one function, you need to be a function first of all. So we wouldn't even test if it passes the horizontal line test unless it already passes the vertical line test. So it also cannot possibly be a one-to-one function, right? When we were saying one-to-one, we were referring to it as a function, and if it's not a function, it can't possibly be one-to-one. All right. Okay, so just be careful with that. In this next example here, the x values. So where are the first coordinates ranging? Well, it looks like it continues on in the negatives over here. Keeps going. There's definitely x coordinates that range over this whole thing, since these are continuing in both directions. So the domain here is negative infinity to infinity, or you could write all real numbers. What about the range? Now, assuming these are indexed by 1s, so let's say that goes up to 3, and -1, -2, -3. So the y values in this curve are ranging between -3 and 3, but there's no part of the red curve that goes beyond this in the negative direction or beyond this in the positive direction. So it looks like the range would be from -3 to 3. However, we have a similar situation. Now here it's quite interesting, right? So let's draw some vertical lines, right? So vertical line here, and we're hitting the curve in 3 places, okay? And that's a problem. So again, this is not going to be a function. Why is that? Well, remember, your domain is supposed to be, those are supposed to essentially be your inputs, right? So if -2 was an input for a function, then it would have 3 outputs, and that's not the way a function is defined. If I give you an input, you're supposed to have 1 and only 1 output, okay? If you're a member of the domain. Okay, so this is not a function. So not a function. Fails the vertical line test. And I have no reason to check whether or not it's one-to-one because it's not even a function to begin with. Although, if you kind of think about the horizontal line test, it looks like it actually passes it. But if you consider the horizontal line y equals 3, do you see that it actually is hitting infinitely many points on that curve? So it actually doesn't even pass the horizontal line test. But it doesn't matter. It's not even a function, so we're not even going to consider whether or not it's one-to-one. So just be aware of that. So not a function, no further necessary classification needed. So in this example here, we have a vertical line. So is a vertical line a function? Well, first let's classify the domain, considering that as a set of points, right? The domain, we're only considering the first coordinate. So what are the possible x values? Well, here's 1 and here's 2. So the domain only has one value, right? It only has x equals 2. So the domain, you could write it like this, 2 to 2 inclusive. So the bars are including 2 there. Or since it's only one value, you can actually put them in between these squiggly brackets, right? And just put the number 2 there. And so that designates that it's a set containing just that one value, the number 2. And we just reserve, if you don't want to memorize more things, you can still use interval notation like this, and it's perfectly fine. But it is good to remind yourself of notations like this, and you reserve this to mean a set of these objects, okay? What about the range? Well, the outputs, there are many, many outputs, right? So for example, 0 is an output, right? At this, if I, at this point on the curve, that corresponds to y being 0. But up here, it looks like I'm getting anything I want for that second coordinate, right? Any positive y value or any negative y value. So the range is actually from negative infinity to infinity. Now, is it a function? Well, it doesn't pass the vertical line test, right? Because I could draw the vertical line at x equals 2, and it is hitting not only just multiple times, it's hitting it actually infinitely many times, right? So this fails the vertical line test. So it is not a function. Okay. Now we have an equation that describes that situation. So just because it's not a function doesn't mean there isn't an equation that describes the situation. I could just describe this with x equals 2, and that gives me this vertical line, as we have seen before. But by our definitions, this is not a function. This is not the graph of a function. Okay? In this next example, we're going to use this equation here to graph the relation, and then we're going to find the domain and range for this relation, right? So domain, comma there, range, and then we're going to determine whether or not it's the graph of a function. Okay, so how do we do that? Well, we just use the same strategy that we've been doing before. We're going to try to figure out a collection of points to plot, and then the relation will be filled in by connecting those points. Okay, so let's go -3, -2, -1, 0, 1, 2, 3. So at -3, if I plug that in, then we're getting -3, right, squared minus 9, so that's 9 minus 9. So that's 0. So that gives us a point, right? -3, 0. So -1, -2, -3, 0. Okay. If I plug in -2 and square that, then we get a 4. 4 minus 9 is -5. And then if I plug in -1, I get and square it, then I get 1. Minus 9 is -8. 0 minus 9 is -9. 1 minus 9 is -8. 2 squared is 4. 4 minus 9 is -5. And then 3 squared is 9. Minus 9 is 0. Okay, so what are our points here? So -2 and then -5. So looking at our outputs are 0, -5, -8, -9. So we don't have, if we index this by ones, it's not going to work out so well for us. So let's do by 2. So -2, -4, -6, and -8, and then -10. Okay, so -2, -5. -1, -8, and then 0, -9, 1, -8, 2, -5, 3, 0. Okay, so then the graph, let me switch to a different color here, maybe red. The graph of this relation will connect these points, but there's going to actually be infinitely many points, but let's just do our best to try to draw this. We'll see later on that this is what's called a parabola. Okay, and this continues on. All right, so now we can solve this as if it was one of the problems up above. So if we were given this curve here, now we can determine the domain, range, and indicate whether or not it's the graph of a function. So what would the domain be? So domain, so those are the x values, right, for the things on this curve. Well, it looks like we're getting all the x values, right? So for between here and here, from like -3 to 3, we're getting all those x values, but it's going to continue on. So the domain looks like it's from -infinity to infinity without restriction. but the range is definitely restricted because there is a smallest output that we're actually getting, right? And then it keeps growing in this direction to positive infinity, and it keeps growing in this direction to positive infinity. So it is going to go to positive infinity, but what is the smallest value? Well, it's down here, right, at negative 9, which we actually found inputs that get us there, right? At 0, we're getting down here to negative 9. And then that's as far as we go in the negative direction. Okay, so that's the domain and the range. Now, looking at the red curve, is that actually a function? Well, if you draw any vertical line, then that is a function. So this is a function because it passes the vertical line test. So that means it's a function. It is a function. And now that we know that it's a function, we could try to further classify whether or not it's one-to-one. But it does not pass the horizontal line test. For example, if you drew a horizontal line here, you know what, let me just fill that in. You'd see that it doesn't, it hits the curve in 2 spots. So it does not pass the horizontal line test. So fails the horizontal line test. So the function is not one-to-one. Okay, now down here we have a slightly different relation. So x is equal to y squared minus 1. So x is equal to y squared minus 1. So I could make a table again. But see, what's interesting is if I pick a y, then I can plug it in over here and determine what x is. Okay, so let's do something similar. Let's go negative 2, negative 1, 0, 1, 2, see where those points lie. So if we substitute this in, then x will be equal to negative 2 squared minus 1. So that's 4 minus 1, which is 3. So that gives us a point 3, negative 2. And if we plug in negative 1, we'll get 1. 1 minus 1 is 0. So our x value will be 0. If we have y is 0, then this will be minus 1. If y is 1, then that'll be 0. And if y is 2, then we'll have 4 minus 1, which is 3. So we get these points. Let's plot those. So if we index this by 1, 1, 2, 3. So 3, negative 2 is here. 0, minus 1 is here. Negative 1, 0 is here. 0, minus 1, or sorry, 0, 1 is right here. And then 3, 2. So 3 and then 2. The outputs we're also assuming are indexed by 1s. Okay, so the curve has to connect these points, and then it should continue on. So what would that actually look like? Well, it kind of looks like a tilted version of the parabola that we had before. So first connect them, right? Connect the dots. It's sort of like like this, and it will continue on, right? Since we only picked a few values, but it's certainly there are many, many more values. Okay, so once we have this, we can solve it just like what we were doing before. What's the domain? What are the x values? Well, those range from this smallest x value over here, which is negative 1, but then they keep growing, right? So all the way to positive infinity. And then the range, is that restricted at all? Well, we start to have positive outputs in this part of the curve, but then it keeps growing, right? And since this is an arrow, it indicates that these y values keep growing. It looks like it's going to grow very slowly, but nonetheless, it'll keep continuing. So it will go to positive infinity. What about negative infinity? Well, once we're over here, the curve is starting to get more and more negative, and it will slowly go, but it will eventually, keep going, and you can get as negative, far as into the negatives as you want. So it actually does go from negative infinity to infinity. Now, is it a function? Well, if you pick a line like this one, a vertical line, right? It unfortunately hits the curve in 2 locations, which means that it is not a function. So it does not pass the vertical line test, right? So that means it is not a function. It is not a function.